Google just signed a deal to buy 200 megawatts of electricity. There's nothing really unusual about that. They buy massive amounts of power all the time for their AI and data centers. But the twist is that the power is supposed to come from a fusion reactor, one that hasn't even been built yet, and it won't turn on until the early 2030s at the earliest. So that's kind of aiming to do something that we've never done before, in a sense, creating energy the same way that our sun creates energy. In June 2025, Google became the first major customer for Commonwealth Fusion Systems' proposed plant in Virginia. And this isn't just about research funding, it's a power purchase agreement for real electricity. So let me explain a little bit about what's going on. Okay, so I mentioned that Google signed this power purchase agreement with Commonwealth Fusion Systems, and half the total output from their first commercial fusion plant that they call ARC. This plant is going to be built in Chesterfield County, Virginia, and is expected to come online in the early 2030s. So Google didn't just sign the papers, they invested money into CFS on top of their original 2021 investment, bringing their total funding to $3 billion. So that's more money than any fusion startup has ever raised. But the catch is that CFS must prove that their fusion reactor works. This first one is called SPARC, and they need to show that it can achieve a net energy gain, which means producing more energy than it consumes. SPARC is under construction outside Boston right now and is expected to begin tests in 2026, with results likely in 2027. So if SPARC succeeds, it paves the way for building ARC, which will be Google's fusion source for some of their electricity. So I mentioned that fusion is the process that the sun creates energy. It's the power behind our stars. You fuse hydrogen atoms into helium under extreme temperatures and pressures, releasing vast amounts of energy. On Earth, this requires heating plasma, an ultra-hot, electrically charged state of matter, to around 100 million degrees Celsius. So that's hotter than the core of the sun. The challenge is containing that plasma long enough for fusion reactions to happen reliably. CFS uses a machine called a tokamak, essentially a giant magnetic donut. It's super powerful magnetic fields generated by high-temperature superconducting magnets that trap and stabilize the plasma, keeping it from touching the reactor walls. And this magnet tech is kind of what the breakthrough is. By using next-gen superconductors, CFS can build a smaller and more powerful tokamak than what was possible just a decade ago. So their commercial ARC reactor is designed to generate about 400 megawatts of electricity, on par with a mid-sized fossil fuel power plant. So why does this matter? Because those magnets are going to change the game. Stronger magnets mean you can make the reactor smaller, cheaper, and more efficient, and that's what makes it commercially viable, at least in theory. AI and cloud computing are driving a massive surge in energy demand. So is air conditioning all over the world. Google reportedly procured more than 8 gigawatts of renewable energy in 2024 alone, which is double their 2023 total. Fusion, if it works, creates something very unique. It is clean with no carbon emissions. It is safe with no meltdown risk like fission. It's compact. It can be built near demand with no massive fuel supply needed. And it's also reliable. It runs 24/7 unaffected by weather. So fusion can complement renewables and batteries to provide more baseload power, especially in regions with weak grids or limited renewable resources. It's kind of like the Holy Grail. It's clean energy that doesn't depend on the weather. But let's be clear, fusion is still an enormous technical challenge. And even if SPARC performs perfectly, it doesn't guarantee that ARC will work as a commercial power source. Can plasma be maintained steadily for long durations? Can reactor components survive years of intense radiation and heat? Can fusion compete on cost with wind, solar, and batteries? Those are questions we still have. But what's exciting now is that fusion is no longer just a lab experiment. It's actually starting to look like it could be an energy industry on itself. And now companies are saying, we'll buy that fusion power if you can make it. And we'll buy it soon, especially with the 2030 deadline kind of coming up. So whether fusion lives up to that promise depends entirely what happens when SPARC switches on. If it works, we may see grid-connected fusion within the next decade, and if not, the timeline may stretch out decades longer. But the race is on, and the money is real, and fusion's future suddenly seems very real. So I'm curious what you think about fusion, if we should be bringing that power of the sun down to Earth in a sense. Drop a comment below and have a wonderful day.